Math 3, Unit 8, Module 4, Topic 1, Lesson 2 Notes, Periodic Functions. A periodic function is a function whose values repeat over regular intervals. The period of a periodic function is the length of the smallest interval over which the function repeats. So basically it's however many x values it takes to create one full cycle before the graph starts repeating itself, before it starts over again. When you look at the next section, we're going to determine the period of the following functions. So on number 1, you start here at an x value of 0, and then you go down, you go up, and then you get back to the value of 0 before the graph is going to continue repeating itself. So all I'm doing is I'm looking at an x value of 0 and an x value of 4 pi, and I want to know how long it takes to get from 0 to 4 pi. So your answer is just 4 pi. It's easy when you start with an x value of 0. If you don't start at an x value of 0, you'd want to do the large x value minus the small x value to get the period. So 4 pi minus 0 would be 4 pi. So that's the distance it takes along the x-axis to create one full cycle before the graph starts repeating itself. When you look at number 2, you could look at quite a few different spots on this graph. Again, if you're able to start at an x value of 0, that's probably the easiest way to visualize it. So basically I'm right here. I go all the way up, back down to the bottom, and then all the way back up here again. So, whoopsies. So if you look at the part I just drew, that is one full cycle. If I switch my colors, you'll notice the part in purple and then the part in orange, it's this exact same thing. So the purple and the orange, it's the same cycle. So we basically want to say, how long did it take along the x-axis? How long did it take to do one of those cycles? So either the purple or the orange, either one. So if you look at the purple one, you go from an x value of 0 to an x value of pi. So pi minus 0 is pi. If you look at the orange cycle, the large x value is right here, so that's a 2 pi. The smaller x value of that orange curve is pi. So you want to do this bigger x value minus the smaller x value. So 2 pi minus pi is pi. All that's saying is that this graph completes one full cycle in pi. So that's the distance along the x-axis that it takes to do one full cycle. Looking at number 3, if you can start at an x value of 0, that's probably the easiest thing to do. So on this one, I'm going up, down, and then back up to the middle. The key with doing one full cycle is making sure that you're starting and stopping at the same y value and that you've done one full cycle before it starts repeating itself. So for example, if I only went in purple here, if I only went here to here, so if I only went from there to there, yes, I started at the same y value, 0, and then went up and then went back down to a y value of 0. But the problem is, if I keep going on this graph, I don't start repeating the exact same thing. I'm doing something different. I'm going down. So you have to make sure that you're doing one full cycle. And again, you have to start and stop at the same y value. Otherwise, you haven't actually completed a full cycle. So on this particular picture, let me get rid of that purple stuff. So on this particular picture, I started at an x value of 0, and then I ended at an x value of 8. So you'd want to do the large x value minus the small x value, and that would mean that the period is 8. Another option that I haven't mentioned yet, I have been going from a middle value to a middle value. You could go from a peak to a peak, or from a valley to a valley. So what I mean by that is, if I look right here, this would be a peak, and then right here, this would be a peak. So I could go like this red part here. I could go like that. That's one full cycle before the graph starts repeating itself again. So the x value over here is -6, and the x value over here is 2. So if I do the large x value minus the small x value, so 2 minus -6, I still get a period of 8. Another option, you could go what I like to call valley to valley, or low point to low point. So I could go, for example, this green point and go up and then down like this to this green point. That's one full cycle before the graph starts repeating itself. So this is an x value of -10 for here. This is an x value of 2. So if I do, -2. So if I do the large x value of -2 minus the small x value of -10, I still get 8. So it doesn't matter what part of the graph you're looking at, as long as you're doing one full cycle before the graph starts repeating itself, and then as long as you're doing the large x value minus the small x value, that should give you the period, because the period is how long it takes to complete one full cycle before you start repeating yourself. Period is usually the most challenging thing for people to do with these types of functions. Everything else we do today in this lesson is not as tricky as period for most students. So next section in this box here, this is just a bunch of vocabulary. So maximum value is the highest y values on the graph. Minimum value is the lowest y values on the graph. And then there's this thing called midline. The midline of a periodic function is a reference line whose equation is the average of the minimum and maximum values of the function. So the equation for midline is y equals the maximum plus the minimum divided by 2. The amplitude of a periodic function is 1/2 the absolute value of the difference between the maximum and the minimum values of the function. So that would be this equation right here. A for amplitude equals 1/2 absolute value maximum minus minimum. Another way to think about amplitude is the fact that it's the distance from the midline up to the top, to the max value, or from that midline down to the bottom, to the minimum value. So here's a max value up there, there's a minimum up there. That distance is the amplitude. And then your midline is this dotted line right here, that guy. That's your midline. And then your amplitude is right here. Okay, that's your amplitude. So let's actually try this out. So we're going to use the graph to identify the following characteristics. For the period, I'm going to try to start with an x value of 0, and then I can show you a couple different ways to look at it. So I'm going to start on my y-axis, and I'm going to go down, up, and then I have to get back to where I started. So I started at a y value of 1, so I'm going to stop at a y value of 1. So that red part right there, I have a x value of 2 pi, and then I have an x value of 0. So I do my large x value minus my small x value to get an answer of 2 pi for the period. Another way I could have looked at this, I could have done peak to peak. So highest point to next highest point. So here to here. So this is an x value of 3 pi over 2, and this is an x value of -pi over 2. So I would do the large x value minus the small x value. So 3 pi over 2 minus -pi over 2. Remember that double negative turns into a positive. So 3 pi plus pi would be 4 pi over 2, which is just 2 pi. So the last way to think about it, you could have done valley to valley. So valley, lowest point, to next lowest point. So this green part here. So that's an x value of 5 pi over 2 and an x value of pi over 2. So I would want to do the large x value, 5 pi over 2, minus the small x value, pi over 2. So that would be 5 pi minus pi up top is 4 pi, divided by 2 is 2 pi. So no matter what part of the graph I looked at, as long as I did one cycle, that shows me my period, the distance it takes along the x-axis to do one full cycle before the graph starts repeating itself. For part B, we want the maximum value. So literally just saying what's the highest y value. So for example, if I just look right here, that point is the highest point on the graph. It has a y value of 4. For the minimum, something like right here. This is the lowest point on the graph. It has a y value of -2. So that is your minimum. Amplitude, we said, was 1/2 the absolute value of the maximum minus the minimum. So 1/2 absolute value of 6, which is 3. Keep in mind that's also the distance from the midline up to either the max or down to the minimum. And I'll show you that visually on the graph in just a second. Let's do midline first because that'll make it easier to show you. So midline's always going to be the equation of the line that cuts right through the center of the graph so that you have the same amount above the midline and then the same amount below the midline. So midline's going to be y equals the maximum plus the minimum divided by 2. So 4 minus 2 is 2. 2 divided by 2 is 1. So y equals 1. And it does need the y equals. You can't just say 1 because it's the equation of the vertical line. So if I draw this in right here in purple, that's my midline at y equals 1. And remember, if we connect this back to amplitude, we're saying that this is 3 units to get up to the max from the midline, and then it's 3 units to get down to the minimum from the midline. So that's how you know that you're right smack dab in the middle. It's the same distance to get up to the top as it is to get down to the bottom from the middle, from the midline. Why don't you pause the video and try number 5? Now that you've tried 5, let's go over it. So I'm going to shorten this up a little bit. On the period for part A, I'm not going to show you all the options. I'm just going to do what I think it looks the easiest on this one. So I'm going to go peak to peak. And the reason I'm going peak to peak as opposed to the middle to the middle, on the y-axis, this point right here is a decimal. Looks like it's probably 1.5. It's just a little bit harder to visualize it. So that's why I'm going to go peak to peak, because those values hit nicely, not at decimals. So that's why I'm going to go peak to peak. So this is an x value of 10. This is an x value of 2. So 10 minus 2 equals 8. So the period's 8. For the maximum value, I'm just looking right up here. This max value, I'm looking for the y value of that point. So it's 5. For the minimum, I'm looking right down here. I want the lowest y value on the graph, so that's -2. And then for amplitude, I'm going to do A equals the absolute, 1/2 times the absolute value of the max minus the minimum. So 1/2 times the absolute value of 7 equals 3.5. It's okay if our amplitude is a decimal, that's fine. For midline, y equals the max plus the min divided by 2. So again, it's okay that our midline is a decimal. Y equals 1.5, that's fine. So visually on the graph, my midline would be right about here at 1.5. So the distance from here to here is 3.5, And then the distance from our midline down to our minimum value is also 3.5. So you can kind of double check yourself at the end and make sure your amplitude and midline match up with each other correctly. Pause the video and try number 6. So on number 6, the period is how long it takes to do one full cycle before the graph starts repeating itself. So I'm just going to do peak to peak. I have an x value of 0.5 and an x value of 0. So do the bigger x value minus the smaller x value to get that the period is 0.5. Maximum is my highest y value, so -1. It's okay that our maximum is negative because this entire graph has negative y values. Our minimum's down here. That looks like it's a -5. Be careful looking at your y-axis. It looks like it's going by 0.5 instead of going by ones. So just be aware of that when you're trying to look at your graph. You always want to check your axes and see how they're labeled and what the scale is. For amplitude, amplitude is 1/2 times the absolute value of the maximum minus the minimum. So -1 plus 5 would be 4, and then you get 2 for your amplitude. Midline is y equals the maximum plus the minimum divided by 2. You're literally just averaging the highest point and the lowest point. You're just averaging it. So that should be -3. And remember, I do need you to write y equals, not just the -3. I need the y equals because that's the equation of that horizontal line that I just drew in, that pink one. Every single point on that pink line has a y value of -3. And then you'll notice it's 2 units to get up to -1, and then 2 units to get down to the minimum. And remember, that's because this graph on the y-axis is going by 0.5s, it's not going by ones.